Yeah, I mean, thank you, Enzo, and thank you, Gopal, for a very interesting talk. And as Dr. Nick would say, hello everyone, or hello everybody. And also I want to say thank you for taking the time to listen to me. Hopefully it'll be more interesting than binge watching The Office for the third time, as we've been doing on the lockdown. Obviously, I can't hear if there's crickets in the room or you're laughing, so I'm going to pretend that my jokes land perfectly. And basically, I'm going to talk about something I've been doing for the last 6 months. However, first, let me talk a little bit about myself. In real life, people know me as Pablo, but on the internet, you might know me more as Pablisco. And for the most part, I'm an Android developer, and I've been working as a contractor for about a couple of years and in different other projects before. So I come from a place that very few people can pronounce where I live, which is Zaragoza. And basically, I live at the moment in North London. I've been living here for about at least 6 or 7 years, long time. So also, more specifically, where I am right now is in a shed that I built during the lockdown. So it was kind of productive. And also, when we go back to offices, I might be able to rent this as an Airbnb. Like I can already see the tagline: "Cozy studio with access to garden." It probably sell quite well. And I think this is probably the most fun, except for having torrential rain worth of the Amazonian forest. And at least I know this is waterproof and quite hot, actually. Also, I'm officially allowed to do dad jokes. It's something I've been training for my whole life. And as you can see, I'm a really bad Terminator interpretator as well. Soon I'll be like this. This will be me in a couple of years. But more pertinent, for the last 10 years I've been doing Android, and about 3 or 4 years I've been working on Kotlin. I've been doing things on server, web, and all the bits. And when I get a chance, I help with the Arrow library. Thank you, Pablo, for the mention. It's a really, really good project. You should check it out if you haven't. But you're not here for me. You're here to hear me talk about what I've been working on with AutoModule. So let's talk about AutoModule or Auto-Module. I'm not very consistent on naming. I'll find a correct name at some point. So basically, AutoModule is a plugin, a Gradle plugin to make us lazier, or in a term that management would prefer better, is more effective or efficient when maintaining your build scripts. So let's start first with a little bit of history and see where all this began. All this started in roughly before COVID times. I did this tweet of how you can basically make a very simple DSL to include nested modules thanks to the power of Kotlin with Gradle. Also, KTS Kotlin with Gradle is an amazing job. Like, it was quite not there a couple of years ago, but if you went back to using Groovy, I recommend giving it a try again, because it's really, really well supported at the moment. So let's say, for example, that we have a project with a structure like this. So you have a folder with apps, and then a folder with different client implementations. So the most normal way to include these ones would be with an include function. There you pass all the different paths for the different modules, basically. You can also have in separate lines, or you can even have separate calls to include. So it's different ways of doing it. Another way, this is a bit of a digression, but another way that you might have seen this is to set a custom project directory for each module. That works. The only problem with that is that you get a flattened structure, so you get all your modules one after the other on Gradle, the Gradle preview. On the other hand, with a hierarchy, you can separate things quite nicely. So the good thing about having hierarchy is that you don't have any name clashing, and you can also group different type of modules into by type or by feature, depending on what your project needs, basically. So coming back to what the tweak does, how can we define modules like this? So I'm going to show you roughly the small code that I use to define this, and also something you can use to make your own DSLs similar to this if you need them. So this is basically all the code that is needed, all the code that you need to put in your settings.gradle.kts file to make it happen. This is the entry point. So it's basically a block function that has a scope as a receiver, and inside of this function we create a root scope, and then we apply the block function to it. This basically has the same name as the include function that we get from Gradle, and it's okay. It's a valid overload because the one from Gradle only takes strings. And this is the function where all the magic happens. Okay, this is an invoked operator, which basically it makes it possible to use any object as a function. In this case, the receiver, which is what we see at the left of the invoke, is the string. So we can use the string as if it was a function. So the first thing we do is to calculate the current path for this invocation. So in this case, we take the parent path from the current scope, and then apply this, which in this case will be the string, to get the current path. In the first instance, as you can see at the bottom, the parent path is going to be empty, so it will just return, use the path of colon with the current value, this in this case. Then what we do is going to do some logging for debugging, and then basically use the original include path, module from Gradle. And then if we've provided a block lambda or closure with it, then we create a new scope with the current path, and then apply basically the next closure to it. So this is how we can add either a simple module by just calling the string as if it was a function, or we can start a new parent by providing the closure, where inside of it we're going to basically create more modules. There is no limit of how many levels you want to have, but when you go over 3, it starts to get a little bit confusing. So while doing this, I got an idea. What does every module in your project have in common? They all have a build script. Whether it's in Groovy or in Kotlin, every one of them has a build script. So I decided to make a new version of my script. And in this version, I wanted to look for all the modules available by looking up scripts. And I came up with this solution. I know it's a lot of code, so let's go through a little by little. But basically what this is doing is finding the location of all the modules that we have available in the root project, basically. I'm going through this because this is basically the base, or where everything from AutoModule started, and I think it's quite interesting. It has some concepts of functional programming as well, as I will say in a minute. So first we start with a sequence of files. This nice function basically allows you to create a sequence of files from a root file. As you might already know, a sequence is lazily evaluated, which I'll go more in a bit. So the next thing we do is basically filter only the files that contain the magic words, which is build.gradle. So we're going to find all the build scripts that are available in basically inside the root folder. Then we're going to go back up, and we're going to get the parent file. So in this case will be the directory that contains that script, which will give us basically a potential path for a module. Then what we do is we remove basically like empty folders, no, empty, sorry, hidden folders, which are start with a dot. We also remove the build source folder, which we don't want to include. And we also remove the root folder because we don't care about that one. Next, we want to convert the folder into an actual path that we can include. So we take the full path, we remove the root directory from it, which gives us the relative path to it. And then we replace all the separator characters by a semicolon. Obviously, best to use separator character instead of just assuming that everybody uses slash, because if you go to Windows, you realize that, oops, that script don't work, and all your colleagues that use Windows, they might not be too happy about it. So next, we're going to do, what we want to do is include all these paths that we've calculated and add them as before with the include path. This is what is called a side effect. This is, again, another functional programming concept, and it's basically just going to do something outside, and it's not going to affect the sequence of objects. The interesting thing is that up to here, nothing has happened. All we've done is set a sequence of operations, if you pardon the pun. And then until we use terminal operation, like for each, nothing is evaluated. So at this point is when everything is getting evaluated and all the calculations that we compiled are getting reduced into a for each. And in this for each, we're basically just going to log the fact that we've included a certain module. A good analogy for this I quite like is a bit like I can never say that word, Schrodinger's cat. Until you do the terminal operation to open the box, you don't know whether the cat is dead or alive. So, yeah. And when we run it, we can see that effectively is the console outputs everything that we expected. All the modules are added. And if we look at the Gradle project structure, it has what we expected. So, of course, I couldn't stop there. And this got me thinking, I could generate something else. So I decided to do a bit of extra code to basically generate some a hierarchy of types inside the build source. The build source folder, if you don't know, is a place that your build script will pick up code, and then basically you can use it in the class path of the project build script, basically. So by doing this, it means that we can, I mean, I'm not going to go into the code of this because it's a little bit complex and I would say quite messy, but you can look at the linker for down below. Basically, what it means is that we can have type safety, so we can start typing local.client, and then it will complete to different projects that we have available. So the good thing about that is that if you change a module, it would automatically be an error saying this module doesn't exist anymore. So it gives you a bit more safety instead of just using strings. I could have stopped there. It works well, it's clean, but I had to do a bit more. Boy, I was in for a journey. Well, it was a guest on GitHub. Guest became a plugin, and that's what AutoModule was. I don't have any music to play, but you can imagine as if my technician was playing. So let's. I'm not going to go too much into detail, but let's go through some of the features that AutoModule has to offer. So one of the things that I added very early, once it was completed, the great thing is that now instead of having all that code on your settings, all you have to do is these 3 lines that include the plugin into your build script, and that's it. You don't have to do anything else, right? So, the other thing is it's changed a little bit, and the project is still in development, although it's fairly stable. So things have changed. It might change back. I would really appreciate feedback when people try it and let me know what's the best way to use it. because obviously different people have different needs for the projects. So let's see what extras that we get with AutoModule. So one of the first things I realized when I was developing the plugin is that sometimes, there's something I forgot to mention, is that I'm actually using the plugin inside the plugin, which is very meta. One of the things I realized when I was doing the plugin is that sometimes you might have modules that you don't want to have included. So you want to be able to ignore them. So one of the ways you can ignore it is by adding a .ignore into the build script, or you can add them to the ignore function in the DSL that the plugin provides. Some of the reasons might be that you might have a module that is not compiling, or you try new technology, so you don't want to have your CI fail because you have something that is on the bleeding edge, but you still want to have it safe because, backups, things happen, and you might lose it. You don't want to lose it, basically. So the original solution relied on generating code, as I explained, on the build source. And basically, Gradle will pick up these files and allow you to use them on the build script. Instead, I decided to move from build scripts to Composite Builds. Basically, if you don't know what a Composite Build is a standalone. Not module, but complete project, like a standalone Gradle project that you can include into the build. So it will be included. So if you have a plugin, then you can add it to your build script. So it does basically something similar to what build source folder does. However, it has some benefits, which is that it uses Gradle's cache mechanism, as well as it allows you to have multiple build modules or build projects. So you can separate your different tools that you have into different places, which, separation is always good. You don't want to get things too complex in one single place. Also, currently the build source gets compiled, and if you have tests, then your build source gets run every time. With Composite Builds, because it uses caches, you don't have that problem. So I decided to add it to the .gradle folder, and basically, when it generates all the code that's using the build source, is creating in the .gradle folder, which is never committed to Git, so it's never committed to source control. And then I use this little trick, which is to use dependency substitution to allow me to basically. Let me focus on that. Yeah. So this little trick, what it's doing is basically adding the code on that include build, because normally you will just include build and then apply a plugin that you have on that module. However, if you don't have a plugin, there's no need to include that. So the benefits of this is that then you don't have to have a dependency on Gradle on your local project. Okay, so code generation. How does AutoModule generates the code? So similar to what the code had before, but a little bit more complex, and adding some options to customize things for your needs with the ignore, for example. I compose a graph of modules in the project. Then I use Kotlin Poet to generate the code, which gets added to the hidden modules project. I use project and module independently. They're both the same. It's a bit confusing, but they basically mean the same. And then I have a custom file DSL that allows me to write things. I call it file tree. I don't go much into detail, but basically this is a very, very tiny API that allows you to write file structure in a very quick way. So something like this, you can have parent, child, and then files, and you can do empty files. You can do a file of content. So that way allows me to basically write the code that needs to be written down. Yeah, that's it. So the next feature that I added was template tasks. This is an interesting one. It came about because of this mini DSL for writing files. I thought could be something interesting with this. So basically, you can define a template that would generate code for a module, for example, or a feature, or anything that you want to write. It's fairly flexible, and it's quite useful because it allows people to be more encouraged to create new modules, because you wanna have not too many modules, but at least encouraged to have separation of modules. And usually, when you have to set up a module, you have that hurdle of having to create a module, which is a bit complicated sometimes. Not complicated, but it's tedious, basically. So the idea of this is that this template will create a task, and when you run the task, it basically generates the code that you need. That said, it's not stable yet. It's in early stages, so you can try it at your own risk. I would appreciate any feedback that you can give me on this. Be quite useful. Another quite recent addition is the ability for AutoModule to also pick up build modules and add them to the build script, similar to how both modules are picked up in normal modules. If you have a module inside Gradle like this, then it will pick it up and add it to the build script without you having to do anything. I use it in the plugin itself to basically organize my dependencies, and also to check the version of the plugin before I do a release, whether I need to do a release or not. Inside, there's a little bit of snippet of how the code works inside the plugin. It basically looks up for any folders or any scripts, similar to what it was doing with the modules, with normal modules. Inside the Gradle, you can change the name of the root where you want to have your build your build modules. And basically, looks for them up and then includes them into the build script, and it also includes them into the class path without having to apply the plugin or even create a plugin at all. So, this is what I was saying. This is the little hack that I showed you earlier. The good thing is that, for example, in my Maven version check build module for the script, there's no dependency of the Gradle API, so it's just a plain Kotlin module, and you could even later on extract it if you want to use it somewhere else, or basically it simplifies how basically it doesn't have so many dependencies in third-party tools. Again, this is the code that basically checks for the versions of the AutoModule internally, and it's just plain Java, plain Kotlin. Oh, don't want to say that word. And then inside the build script, you can directly use it. There's no need to use extensions. There's no need to use custom plugins or tasks or anything like that. It's all there. Do we have a question? No. One last thing, one of the latest recent additions is the option to hold versions in a centralized place. Basically, you have versions of the property file, which contains all your versions. And then in your code, instead of having to provide the version, it automatically finds the version for you. And that also works for plugins. Unfortunately, it doesn't work for AutoModule. So AutoModule will be the only version that you have to put in your build scripts. Now for future, what's the future of this library? So I'm hoping to have version 1.0 soon. There might be a potential name change. I'm open to suggestions if anyone has a good idea. I'm thinking auto settings, maybe something like that. I'm thinking of splitting the plugin into multiple ones, because as you can see, it's a little bit of a feature creep at the moment. So I want to make the plugins a bit more easy to manage and develop. Also improve the templating system, which is a bit in a raw state at the moment, and also add extra features for the version resolution. But that said, I need you to help me, because one, I have limited time, especially with baby, and also I don't have access to the thousands of projects that people have available. So if you if you get a chance to just have a try in a branch on your project with your team and check it out, see if it works for you, see what you could gain from it, or if there's something that you would prefer is done in a different way, I would really appreciate any pull requests and issues that you might have. And since I'm asking, I can also help you. I'm currently, I don't have a client at the moment, so I'm available if you need help with your team. If you need help upgrading to using Kotlin with Gradle, or general Gradle performance issues. I also do Kotlin training, Android development, and also functional programming. All these things, if you need, I'm available. So you can hit me up in Twitter. If you search Pablo online, I'm there. That's it. Let's do some questions, I think.
Thank you. Yes, we have questions. Sorry for being up too soon. So can you see them?
Mm-hmm.
Okay.
Sure. So AutoModule is designed for multi-platform projects, or can it be used for under multi-module too? That's a good question. There is no need to be multi-platform because Gradle is just JVM. So basically, it will work with anything. Again, if you want to try and let me know if there's any errors or any problems, which I'm sure there are. So let me know, and I can have a look. The second part of that one. And if that's the case, why not use sub-projects in your root builds as it appears to serve the same purpose? I'm not sure I understand that question. So sub-projects is a function that allows you to apply things on sub-projects. Yeah, I'll have to get back to that. If you want to hit me on Twitter, then we can have a chat about that one. So, there's one from Paco. Rumor is you are working on a version of Arrow for Flutter. How is the progress? That was a try. Yeah. A bit unrelated, but that was a try on that one. It was somebody else that did a better version of that, so we decided not to go with that one. I think I need to go back to talk to the guys, see if we can bring it to our room. That'd be quite ideal. And finally, from I'm gonna butcher the name, Crumply. How do you make cyclic dependencies between your sub projects? I haven't had that issue. Because there's no real dependencies at the moment on that. I haven't run into the issue. However, yeah, if you have cyclic dependencies between sub projects, that probably not related to AutoModule. But again, if you want to expand on that on Twitter, let me know and we can have a look.
Cool. That was it. Thanks so much. Thanks for stepping in and
thank you.
duty for co-organizer.